In the first part of the nitrogen cycle, we got to hear that nitrogen can be added to the ground through lightning bolts, beneficial organisms that can take it from the air and give it to the plant roots. And then there's a process where ammonia gets turned to nitrates by other bacteria in the soil. And there's actually like a dozen more, but that's way beyond the scope of this. And this is what it looks like here. We can have what they call nitrogen fixation. Either these root nodules eat it, or lightning bolts rain it out onto the plant as nitrates. When the bunny eats our little photosynthetic strawberry and he excretes ammonia, there are other soil bacteria that drag the ammonia back to nitrates. I mean, they don't walk it over to the plant, but I can't pile this all up on the poor little strawberry plant or you won't see it. Right? The thing would look like it's under assault. Lightning bolts here, bunny peeing on it and eating it, but in the same vicinity. And like I said, if the bunny pees right here, you're going to see grass blooming on either side of it, not directly on the spot that was hit. So that's your nitrogen fixation on this side. And they call this nitrification. And again, it's a really irritating distinction um, between the two processes. So nitrification converts a liquid compound to a one that plants can use, where nitrogen fixation literally nails down the nitrogen gas out of the air. The old term fix, like fix that sail in a movie, means to hammer something down, tie it down. So that's why they call the lightning bolt nitrogen fixation and these guys. Now, here's where the conflict arises. We have three processes that remove nitrogen gas from the air and convert it to a solid or liquid form that circulate between plants and animals. So between lightning bolts and these root nodules, nitrogen is dragged out of the air and converted into a solid or liquid. And then when the bunnies or humans eat plants or anything else and we excrete waste, the ammonia that's created gets turned back into nitrates. So we have three processes that can drag nitrogen gas out of the Earth's atmosphere. Okay, so there's a constant downward pull on nitrogen to bring it into the Earth and make it solid or liquid. Yet in all of the history of nitrogen in the Earth's atmosphere, it's remained at 78%. Okay, so we got a conflict here. Three processes removing nitrogen from the atmosphere, yet atmosphere or nitrogen remains at 78%, which it really should drop. So go back to the SIS slideshow on contradictions. Here are the two conflicting statements. If three processes are removing nitrogen, the level should fall to zero, yet the level remains at 78%. Okay? Are you going to just accept those two facts and just not do anything with that? Or do you see there's something wrong here and that there's a chance for discovery? These are the moments where you have to decide, do I just accept two conflicting facts, assume I'm stupid, I don't like this course, I want to quit? Or do you go, this is telling me something, I'm missing a piece of the puzzle? And that's what you should be looking for all the time if you want to practice science. So here's the answer. If you think about it, if there are processes that remove nitrogen from the air and the amount never decreases, then there has to be something that's putting it back. Okay? So while there is a soil bacteria that pulls nitrogen into the soil, at the same time, there must be another bacteria that breaks the nitrates apart and returns it back to gaseous form. This means there's stuff in the soil that are alive and breathing, and it's nitrogen they use. They either breathe nitrogen in or they breathe it out. That sounds exactly like photosynthesis with oxygen and CO2, except now it's N2 and NO3 or NH3. A few more things, but it's a doing and an undoing, and they're perfectly in balance. You can conclude this before you even know they're there. That's your hypothesis. There's soil bacteria that must undo the nitrogen fixation, or we'd run out of nitrogen in the air. So that's the killer moment that a scientist goes, okay, so what are we going to do? We'll get a baggie, put it over some plants, and see if nitrogen builds up. They'll start looking for it, and they've found it. Okay? And I didn't actually expect you to totally solve this on your own, because if you go up here and see, I deliberately did not read this sentence right there, and I didn't number it as point 4. I tricked you. It was sitting right in front of your face. And right here, I didn't comment on this arrow E. It was sitting right there in front of you. That's the denitrification process. So we have two processes that trap nitrogen, and this third one is called denitrification that spits them back. I left them sitting right in front of your face to lead you to this. Okay? The last part we're going to look at is disrupting the nitrogen cycle. And again, I'm going to pause the video here because I have a 10-minute recording time. And it tends to cut out smack in the middle of my sentences. So we'll be back in just a moment.